Hi there everyone. This video we're going to be looking at scientific notation, or standard form is another word for that, and also looking at how we round numbers to a certain number of significant figures. So I'm sure you've seen scientific notation before, I'm sure. It's just a way of writing really big or really small numbers in this form down here. So a number, which is going to be between 1 and 10, times 10 to the power of some number where that power there is an integer, a positive or negative whole number. So it's really easy to convert between these. So if I start with 180, first of all I've got to think of what's the number that I can make out of that between 1 and 10, that's 1.8. And in this case, to get from 1.8 to 180, I'd have to move the decimal place over twice. So that is written in standard form like that now. I had a small number, 0054. I look at the digits, think, what's a number between 1 and 10 that I can make from those digits? And that'll be 5.4. Now to get from 5.4 back to looking like this, I would have to move the decimal place back 3. So in this case here, the power is times 10 to the negative 3. Okay, you can always check that. These are really easily done on your calculator as well. So converting in between those should be really easy for you, and you should have seen those before as well. You might need to use your calculator to do things like this. You've got a number in standard form, 2 times 10 to the power of 6 times 6 times 10 to the power of 5. In this one here, we're going to split them up separately. So you'd say that that's 2 times 6, 12. And then 10 to the 6 times 10 to the 5 is 10 to the 11. Now that's the correct answer, but that is not in standard form. Remember, we always need a number here that's between 1 and 10. So 12 times 10 to the 11 is going to be 1.2 times 10 to the power of 12. Okay, so now that's a number here that is between 1 and 10, and you get the same answer as we did before. Okay, let's talk about rounding now to a certain number of significant figures. In this little example that we've got here, we're talking about attending a football game, and the crowd size was 95,446. Now the newspaper said there was 95,000 people there. So is that correct? Well, it is, because they've rounded it to a certain number of significant figures. So we know how to round to a certain number of decimal places. So significant figures just allows us to round big numbers that don't involve decimals, but also round them to a certain number of significant figures. So yes, all numbers are significant, but some numbers we don't need when we're writing down the number. They're kind of there just as placeholders. So we're talking about zeros here. So all numbers themselves are significant. We're only talking about zeros, some of which are not significant. So in general, here's the rules. Digits are significant if they're not zero. If there is a zero between two non-zero digits, so 3, 0, 0, 5, those two zeros there will be significant. Trailing zeros on a number containing a decimal point, they are significant. Now the reason for that is if I write 39 degrees for a temperature, or if I write 39.0 degrees, the fact that I didn't have to write that 0 in the second one shows that it's significant. And it shows that that second measurement is probably rounded to the nearest tenth of a degree, whereas the first one was rounded to the nearest degree. Okay, and all digits in a number using scientific notation are significant. So let's look at this number here, 7004.040200. Let's look at the significant digits. Firstly, these two, 4, 7, 4, 2, they're significant. These two zeros here are significant because they're between two numbers. So is this one here, it's between this 4 and this 4. This 0 here is between a 4 and a 2, so they're significant. And these ones here, because they didn't have to be written, are significant. So I could have just left those off and it wouldn't have made any difference to what the number is. So every one of those digits there is significant in this thing here. So we would say there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 significant figures. That's a very accurate number. So let's look at this number now, 95,446. To one significant figure, it's closest to 100,000. Okay, so in this case we're wanting to know, is it closer to 90,000 or 100,000? So here it's closer to 100,000. Two significant figures. Now we're looking at the second place in the decimal here. So we're looking at the 5. So is it going to be 95,000 or 94,000? They are the numbers that have two significant figures either side of this number. So we've just got to work out which one is it closer to. Or you could apply the same test you use for rounding decimal places. Look at the next digit along. If that next digit along is between 0 and 4, you stay with where you were. If that's 5 or above, then you round up. So in this case, we've got a 4 in the third position. So the answer we're looking for is 95,000. I'll leave it the same. Three significant figures. Again, we'll look at the third significant digit here, which is the 4. So, and this one here, the fourth one along, tells us whether we should stay with the 4 or go up to 5. In this case here, we want 95,400. Notice I'm not writing 954 for my number rounded to three significant figures. That would be wrong. 954 is nowhere near 95,446. So that's not rounding at all if we do that. So we definitely need to include zeros on the end to get it right. And four significant figures, if we wanted to do it to four significant places. Again, we look at the fourth number, 1, 2, 3, 4. Is the next digit 5 or above? It is, so we're going to go up in this case. 95,450. That would be the number rounded to four significant figures.